Hello everyone, welcome back to our course on unit operation in food process engineering. Today we are going to discuss one of the most important advanced separation techniques used in modern food industries, namely food membrane separation process. So this technology has revitalized food processing because it allows us to separate valuable components without applying high temperatures. So as a result, the nutritional quality, flavors, colors and functional properties of the food are preserved. So during this session, we will understand what membranes are, how membrane separation works, different types of membrane separation process, factors affecting the separation, and finally explore various industrial applications, especially in the dairy and beverage industries. So before understanding membrane separation, let us first understand what a membrane is. A membrane is a very thin layer of material that acts as a selective barrier. It allows certain molecules to pass through while preventing others based on properties such as size, molecular weight, or electrical charge. So membranes may be made from synthetic polymeric materials like polysulfone or cellulose acetate, or inorganic materials such as ceramics. So ceramic membranes are highly durable and can withstand high temperature and harsh cleaning conditions. You can compare a membrane to a kitchen sink. So when we see flour, only the fine particles pass through while larger particles remain behind. Similarly, membrane selective separation molecules. And in food engineering, membranes are widely used because they do not require phase change such as evaporation. This makes the process energy efficient and suitable for heat sensitive food. So now let us define membrane separation. So membrane separation is a pressure-driven separation process in which a semi-permeable membrane separates different components of a liquid or gas mixture. The principle is simple. A pressure difference is created across the membrane. Smaller molecules such as water pass through the membrane and are called permeate. Larger molecules like protein, fat, microorganisms and suspended solid cannot pass through and remain on the feed inside. So this retained portion is known as the retinate. Unlike thermal concentration method, membrane separation occurs at low temperature, making it ideal for preserving nutrients and maintaining food quality. So this technology has become increasingly important in dairy, beverage, pharmaceuticals, biotechnology and water treatment industries. So membrane separation can be classified into four major types depending on the pore size and the material being separated. The first is microfiltration, which has the largest pore size, generally between 0.1 and 10 micrometers. So it removes suspended particles, bacteria and fat globules. The second is ultrafiltration. With much smaller pores, it retains protein while allowing water, lactose and minerals to pass through this. This process is extremely used for whey protein concentration. So the third one is nanofiltration, which is to remove all small organic molecules and multivalent salts. It is commonly used for water softening and partial demineralization. So finally, the reverse osmosis has the small pore size. It removes almost all the solid salts and water molecules and making it suitable for juice concentration, milk concentration and water purification. As the pore size decreased, the separation became more selective, but the operating pressure required becomes higher. So let us understand the working process step by step. So first, the feed solution enters the membrane module. So next, pressure is applied using a pump. This pressure acts as the driving force for the separation. As the liquid flows across the membrane surface, small molecules such as water and dissolved salt pass through the pores. This filtration liquid is called permeate. Meanwhile, larger molecules such as protein, fat globules, microorganisms and suspended solids are retained. This concentrated stream is known as retinate. One important parameter in membrane technology is membrane flux, which represents the quality of the parameter passing through the membrane per unit membrane area per unit time. And higher flux generally indicates better membrane performance, although excessive fouling may reduce it over time. So next we shall see about several factors influencing the efficiency of the membrane separation. So first of all, pressure. So this pressure will affect the membrane by increasing the separation rate. And next one is temperature, which affects the permeability of the solution. And next is membrane pore size, which controls the selective particles to pass through it. And last one is fouling, which reduces the efficiency of the membranes. Therefore, proper cleaning and maintenance are essential for efficient membrane operation. So membrane separation has become inseparable in modern food processing industries. In the dairy engineering, ultrafiltration is used. In beverage industry, membrane filtration is used, and also it is used to concentrate fruit juice without affecting the flavor. In water treatment plants, reverse osmosis removes dissolved salts. In the technology is also applied in pharmaceutical manufacturing, biotechnology, wine clarification, sugar processing, and wastewater treatments. Some important advantages include low temperature processing, high product quality, better nutrition retention, energy efficiency, and environmentally friendly operation. So to summarize, we learned that the membranes are selective barriers used to separate different components of liquid or gas. We discussed the four major membrane processes: micro, ultra, nano, and reverse osmosis. So we understood the working principle involving feed pressure, permeate, and retinate. We also examined the major factors affecting membrane performance and explored the important industrial application. Overall, membrane separation is considered one of the most efficient sustainable separation technology used in the modern technology. So the information present in this lecture is based on the standard references, including NPTEL lectures, the FAO food engineering manuals, and Iowa State University food engineering resources, engineering toolbox, and Encyclopedia Britannica. So I encourage you to refer these sources if you wish to study membrane technology in greater details. So thank you, students, for your interaction and your attention. I hope this lecture has given you a clear understanding of membrane separation process and their significance in food engineering. Thank you. See you in my next video.